told me, sir, we are using scientific calculator, would you accept? We can feed these to teach me. Then there is nothing wrong if I learn from a student. Actually, we learn from the students as teachers. The students will give new ideas. Each day is a lesson for teacher as well as a student. Unless we are having that open mind, we are not teachers. Therefore, these are the things which can be introduced. I think 15 minutes. Then I will just give a glimpse of how to find the table of sine theta in trigonometry. Now, actually, finding the value of pi is adapted by me by seeing the explanation of Aryabhata first, who is the first commentator of Aryabhata Vyakhya, explaining the number of hour signs for 6, 12, 24 hour sign thetas. When I read that one, why should I not apply this to pi, to find the value of pi? Their diameter is different, whereas the diameter is 20,000. May not be same method, but a bit alteration. I tried it, I got it. And I could apply that even to Excel program. I will show about that. I will talk about the Indian place value system and other place value systems. Or sin theta, I am not talking about. This is actually the organization where I am working, and this side is the old senior pontiff is no more, 2 years back, and the present pontiff that side. And this is the organization branches of various sciences. Now we will see the place value system in overview. You should know. Nowadays, the people are fascinated by abacus. Each street in every town, every city, abacus is being taught. After seeing this, you can think about it. Now, the place value system, the chronology is like this. Indians found it in 2500 BC, Babylonians in 2nd millennium BC, Chinese shortly before the beginning of the Christian era, but they may say it was even before man existed. Just like Tamil was existing, same way, Chinese numerals were existing before, and everything was existing. Not only that, and Mayans like this. Though Indians' place value system is the first of all these four, we will talk about the other three to see the importance of the Indian place value system. The place value system was there only in these three civilizations, not in Roman civilization, as you know. You know how to write 1, 2, 3, 4, 5, 6, 7, 8. And you know how we cannot add writing them one below the other in a row as we do now in Roman script, in Roman numerals. We cannot. We have to use either pebbles or some other means to add or subtract or multiply. Now Babylonian numerals are these. These are the 3 digits, but it was for base 60 system. Ours is base 10, therefore we have digits 1 to 9 and 0. We don't say 0 to 9. Why? There is a reason for it. Even the computer keyboard we are having 1 to 9 and lastly 0. Now only these 3 digits were used to write all the 60 digits. Like this is how they were writing. Subtraction rule, addition rule. In the here 40 4 tens minus that middle one, 2, the first this one, end one minus, the middle one 2's. Therefore 40 minus 2 is 38. That is how they were writing 38. Can we write this on the page, one below the other and add them? Not possible. We have to use either pebbles or some means. Even now, here also in primary nursery class we use abacus, money cutter. That's abacus. We have to use that. Otherwise we can use even stones, small stones or any other seed that we are using to start with. Now the same thing to be used for even higher mathematics, higher arithmetic operations. Now Babylonian numerals from 1 to 59 are these. Here you can see only 1 and 3. 1 and 10. 1 and 10. Now 59 in cuneiform, that means they were using stones. They were etching. 59 were etching like this. We don't know. And it is to the base 60. Here 45, 4 into 10 plus 5. Here each digit into 60. 1, 60, 60 square. Like that it goes, base value. Now they say it is 59 in this way. How does it become? Only when I split it, group it. If I group this in this fashion, then only it is 59. 2 into 62 plus 25 into 60 square plus 42 into 60 plus 31. But why should I, when there is no division, why should I divide like that only? There is no instruction. I can also divide like this. This means 2 into 60 to the power 5, there is nothing wrong. 10 into 60 to the power 4 plus 15 into like that, that gives completely different number, numeral of a number. There is a confusion in Babylonians. And the other is, there was no 0. Only 300 BC onwards, they had some symbol for 0, not the 0 that we use. Now Chinese numerals, 1 to 9, are these. You know that even letters, alphabets, are also figures they use. And it is easy for them. Whatever we teach to our children, that is easy to them. However difficult it is. Whatever we teach them when they are child, it is easy. But after that if we teach anything else, though it is easy, it is difficult. Example is Vedic mathematics. My relation, my cousin, is teaching in a NGO, non-government organization, for some not so much financially efficient small children. She teaches first with Vedic mathematics only, not with regular our way of doing it, for multiplication, etc. The preliminary multiplication and other things, 1 to 10, this has to be taught, this has to be learned as others do. But beyond that, they feel it easy, Vedic mathematics method. Buddha Triyajna. Egunena, Purena, Purena. These they use without telling the rules. They use it. They do it as they do multiplication table. But if I teach you also, you find it very difficult. Because our mind is set. Now, China has adopted both 10 value system, place value 10, as well as 18 and 20. A multi-base value system. That's the difficulty. Now, these are the numerals. They are having different numerals for 10. We are having 1, 0, 10. For 100, 1 followed by 2, 0 for us. But for them, this is a symbol. Of course, you can see some similarity. You can compare how they arrive at that symbol, etc. For each one, they are having symbol like this. They can also not able to add by writing them one below the other. Chinese, though they are having place value system. Chinese numeral for 0 is a smiling face because they consider it as a very great one, very special one. Here in North India, they call 0 as Pujya, Pujya. Even in Tamil Nadu, they call it as Pujyam. Because they consider 0 is a new invention and it is very great because it has got very special qualities. What are those? Mayan system is this. Like our olden days, the milk vendor used to come and supply milk, and she used to write 1 with our cow dung smitter, 1, 2, 3, etc. Or afterwards, piece of chalk. She used to bring piece of chalk and write 1, 2, 3, etc. It appears like that. They don't have numeral. She doesn't know, therefore she was writing like that. Mayan numeral system also, it was to the base of 20s and product of 18 and 20s. See here, that symbol, what is shown, is for 43,497. It starts with 20, the next place 20 into 18, next place 20 squared into 18, like that the place values increase. The digit multiplied by place value will give for us place value of the particular number. This is also difficult. These are the things which are using. Even now, it has come back. And they want to teach these things. Hindu Arabic numerals are 1 to 9 and 0 only. Of course, Brahmi numerals are different. Kannada numerals different. Telugu and Kannada same. Tamil and Malayalam same. Numerals. But saying may be different. In this way, Hindi, Sanskrit, Devanagari. In this way, we are having different numerals. Numbers pronunciation also different. Now, the Hindu Arabic numeral system is named after the Hindus who have invented it and the Arabs who transmitted it to Western Europe. It is the Arabs. That is why it is called, they are called Arabic numerals. Hindu Arabic numerals it has to be called. But in PageMaker, if you go there, it asks you, you want Arabic numeral or any other numeral. They are not happy to say it as Hindu. And even now, the politicians also do not call it as Hindu. If you say Hindu, you are rationalist. The book Al-Jabal al-Mukharabla of the Persian mathematician Muhammad bin Musa al-Khwarizmi describing 0 and Persian value for digits popularized Hindu system of numerals in Western Europe. It is actually Muslims who came here and propagated all these things. Chinese also came. Indian 0. Indian 0 is a multifaceted mathematical concept. How? Number, it is 0, whatever you Pujyam, whatever you may call it. And also a numeral, 0. There is a difference between numeral and a number. Number is what we speak of. Numeral is what we write for it, symbol. Venkatesh Murthy is a name. If you show the photograph, Venkatesh Murthy is a symbol. That's all. Now, it is also a magnitude. It shows the length, how far you have gone. I have not moved anywhere. How to represent it? There is no symbol for that. Then they detach it. For the last 3 seconds from this place I have not moved. I want to show it. Should I keep quiet without mentioning anything? I have to show it. I didn't earn any money this week or today. Should I keep quiet? Today what I have earned, I have to write down. I have to write the date. And then what I have earned, I have to show it. What do I show it? 0. It's a magnitude. Then, a direction separator. I moved up. I climbed down. I moved left. I moved right. Number line. That shows direction. 0 is in the center. Center 0 to the right to me, it is positive. To the left to me, it is negative. Up, positive. Down, negative. 0 is a direction separator. Simple. Most important is a placeholder. How it is a placeholder? In the numeral 2009, I will take, not 10. 2009. There I say 29. 2009. I have not said anything. If I don't know anything, I write, I have 2 and 9. I write 2, 9 and leave it. But primary nursery school teacher says, no, you should write it as 2000. There is no 100, 0, 100. There is no 10, 0, 10, 9. Then only you can add them, writing row wise, column wise you can write them. You can add them. Of course, look at it. That is the advantage. Multiplication, division, all basic operations can be done only when we write it using place value system. Though it is not told the place value, the digit is not there. Therefore, 1 to 9 is called figure 8. Figures. Figure A. Z is non-figure A. Now these are the place values. This is about Sanskrit. Skip these things. The place values are denoted in each textbook in different ways. There was no standardization. Afterwards, that is why in each Sanskrit text they write the names of the place values they use. Once standardization is done, there is no necessity. Everyone knows it. But during those days, knowledge was limited to a particular place. It was not transmitted through computer or anything. That is why each one had his own. Vinidasara Sangraha says like that, in that way different. Mahavira Acharya says like this. Ancient Indian mathematics, they had different way. That is why for place value system, number, this big number, circumference of a circle of the sky in Yojana is given this way. Dvadasha laksha saptajattvarinshat sahasra chatushyatati dvisaptati kotayaha panchalakshaha shattasaptati sahasrani. This is the diameter in Yojana of the sky, stated by Acharya in 748 AD, when others were not able to say the place value of the 12. Now, here you can observe 2 is appearing in 2 places, 7 is appearing in 7 places. The same 7 appearing in 7 places. And their values are different. 2, the same, appearing in 2 places. For example, place value of 2 is 2 into 10 to the power of 12, 2 followed by 12 zeros, and another is 2 followed by 7 zeros. For 7, 7 followed by 10 zeros, 8 zeros, 4 zeros. How to distinguish them? Why different names? For that, the beautiful shloka is there, given by Yoga Sutra in 658. Yatha ekarekha shatasthane shatam, dashasthane dashayamcha, ekasthane yatha cha ekatvepi, stri mata cha uchyate, vita swasa cha iti. How the same lady is considered as, called as daughter by her mother, daughter-in-law by her mother-in-law. Like that, different positions, as per her different positions, her name is called. Mother calls, daughter calls her mother. Mother-in-law calls her daughter-in-law. parents also taught. In that way, the same digit occupying different place values have different names. 2222. 2000 because it is occupying 1000 place. 200 because it is 100 place. 22, 2 10 place. 2 8 place, 1 place. A beautiful mnemonic. One can remember how the same digit could be called as different names. There is a beautiful drawing in 1503, one Gregor Risch has written in Margaritica Philosophica. Here you can see a lady, we can call her Saraswati, a goddess of photography. She is having a book and also a writing material, abacus also. And she is looking at a young boy, young man, with present face, having writing material in his hand. He is algorithm. That means place value system. Another person who is having an abacus, beads, with frowned head, old man, looking sorrow. He is an abacist who is the propagator of abacus. And the drawing written by Gregor Risch in 1503 AD forecast abacus will no longer be useful. It is algorithm which will flourish. But unfortunately, in India, abacus are flourishing. That is the fate of our India. Anything which comes from foreign is late. That is why P. Salmon Laplace in 1749 he says about Hindu numeral system. It is India that gave us the ingenious method of expressing all numbers by means of 10 symbols, each receiving a value position as well as an absolute value. Value position means 2 into 10 to the power 2, 200. A profound and important idea which appears so simple to us now that we ignore its true merit. But its very simplicity, the great ease which it has rendered all computations put our arithmetic in the first rank of useful inventions. That is why Einstein says, without the Indian place value system of Hindus, we would not have progressed so much. Even Archimedes and Apollonius, they were using pebbles and other things to show arithmetic in the first rank of useful inventions, and we shall appreciate the grandeur of this achievement when we remind that it escaped the genius of Archimedes and Apollonius. The next one, Dempsey, the famous historian of mathematics, says the long period of 5,000 years saw the rise and fall of many civilizations, each leaving behind it a heritage of literature, art, philosophy, and religion. But what was the achievement in the field of mechanics? The earliest thought practiced in man. The first one who wanted to become materialist. He was a materialist. How much? First man was a materialist, spiritualist of course. What does human when stomach is full, we think about spirituality. When spirituality is not there. Therefore, that is the first invention. Inflexible numeration, so crude as to make progress well nigh impossible, and a calculating device so limited in scope that even the elementary calculations called for the service of an expert for learning multiplication go to Italy. That was the position. Right. Man used these devices for thousands of years without making a single worthwhile improvement in the sensitive instrument, without contributing a single important idea to the system. When viewed in this light, the achievement of an unknown Hindu, he says unknown Hindu, Dempsey. We need not be afraid of saying about such. Here, Hindustan, Pakistan comes, Hindustan. We are afraid. Who discovered the principal position assumes the proportion of world achievement. Thank you very much for giving me this opportunity. Thanks to organizations and Acharya ji, and also the principal of this institution, and all of you for hearing patiently whatever I have said.
I mean, earlier Siddhantas which have been known, which have been found, the manuscript has been found and it has been discussed in detail right from that time onwards, from 489 AD, because there is a commentary which is written in 620 AD under. So it has been studied all the time from there. And this is the first text which will give some mathematical details, some advanced mathematics, advanced for that time, and calculation of planetary longitudes and latitudes and many other problems are discussed in a full mathematical manner. So it mentioned in the text itself that it was composed 3600 years after the beginning of Kali Yuga, which corresponds to 489 AD, and has been mentioned in the book only 121 stanzas. And Aryabhata has composed one more work called Aryabhata Siddhanta, which has not been, it has been referred to by many other people later, but manuscripts of that have not been found. The four parts also have been mentioned by the earlier speakers: Gitika Pada, Ganita Pada, Kalakriya Pada, and Gora Pada. So Gitika Pada in 13th stanza deals with basic definitions, revolution numbers of planets, and parameters associated with them. So this bit of revision for you. Okay. And Ganita Pada in 33 stanza deals with mathematical problems such as squaring, square root, cubing, cube root, area of plane figure, volumes, value of pi, method for finding signs and constructing sign table, summation of series, that is arithmetical progressions, and also sums of squares of integers, the sums of cubes, and so on and so forth. They are discussed for the first time in Aryabhata. And in Kuttaka, that is solution of linear indeterminate equations. I will come to that and discuss in some detail this time. Then Kalakriya Pada in 25 stanza deals with reckoning of time, because Kalamana is the most important thing in India. Then planetary model, having this epicycle and eccentric circle theories are mentioned, and procedure for calculation of planetary positions. And Gaurapada is spherical astronomy, in 50 stanza deals with spherical astronomy, Bhagora, celestial sphere, seen at different latitudes, diurnal problems associated with motion of sun, moon and planets, parallax, lunar eclipse, solar eclipse, and so on. So, as I mentioned earlier by the speakers, it's extremely brief, because so many things have been compressed together in such a small work. As he said, it can be printed pages, it become to only 3 pages. But so many topics have been discussed, so it's extremely brief. So mainly procedures are given, and if you want to understand the subject in more detail, topic in more detail, one has to go to commentaries. So some salient features I will mention again. So while discussing revolution numbers of planets, Sri Venkatesh Murthy spent a lot of time on this revolution numbers of planets. He gave all the numbers also, right? For Shukra, Shani, Buddha, Chandra, Surya, all those things, revolution. How many numbers of revolutions he made in a Mahayuga of 43 lakh 20,000 years. Now, here it is mentioned that the number for Earth is this 158, 22, 37, 500. So this is the number for Earth. So this will amount to actually this is the number of rotations of the Earth. So then so if you calculate this thing, the 43 lakh 20,000 divided by this, so that we are 158, 22, etc. divided by 43, 20. So this thing that will give the number of sidereal days in this year, and each day will correspond to 24 hours. So the sidereal period of rotation of the Earth will be 23 hours.